also have to start. Okay, so I'm Doerthe Arndt from iMinds, Ghent University, and I'm going to talk about using rules to generate and execute workflows in smart factories. So, first of all, I'm going to present the business case. Afterwards, I will talk about the challenges which come with this business case. And then I'll explain a little bit our rule-based solution and the status where we are currently with this project. Okay, so first of all, the business case. We are in smart factories, and we are in factories, and factories are full of computer-controlled devices which can perform service operations. So in our use case, those are normally RESTful API operations, but so there are lots of operations. And an operation could be something like starting or stopping a machine, or also just communication to the user, or storing knowledge. All this is information, or all these are service operations, which could be there in the factory. And now we have the problem. If we really want to do something with this, we have to combine those different service operations into workflows and execute them. Okay, so now you wonder maybe why we want to do that. So why do we have different operations we want to describe and then combine? One thing is, if we do this that way, we can reuse existing services for different workflows. So, don't know, I have two different workflows where I need to know certain data, don't know, or something like that. And then I could reuse that easily, like in programming also. So if this already is lying around somewhere, it's nicer to reuse it. Another thing is, if I describe my service descriptions and not any workflows or something like that, I can easily add or remove services to our system. So it's easy to maintain that. Then it's also nice if the service workflow is composed whenever I need it. It's also flexible enough to cope or to offer different solutions if something fails. So if a service, for example, a sensor temporarily doesn't work, but there's another sensor in the room which could provide the same information, then we could have certain backups for that. Then another reason why we want that is there are some workflows, especially if you want to have certain knowledge or things like that, which don't occur that often, and you might want to have them immediately without programming them before. And with a system like this, it can be, or it will be it could be done that they immediately work, those workflows. So that's the reason why we do that. And then I already mentioned knowledge, but I learned from our industry partners that the knowledge part is important, therefore I added it again. So if we have that, we can really use better knowledge in factories. So they have lots of different sources of information and they want to combine that. And they normally don't do this manually because it's too much work. And if they have systems which can combine different knowledge sources, this is also an advantage. And what we want to do, so all in all, we want to organize factories in a better way. Okay, so next I want to talk about the challenges coming with that. So the challenges are, first of all, our computer system needs to somehow understand different services or service descriptions. So there's this semantics need. Then we have, it should be adaptable, as I already said. So if something does not work as accepted, our system should adapt and find a different path, find a different solution. Then it should be configurable. So if I buy a new machine, it should be easy to add it into my system. Or if I just don't want to use a machine anymore, I should also be able to just remove it. then it should be flexible. Maybe flexible is not. Yeah. What I mean by flexible is it should immediately support viable goals. So if something is there and could be done with my services, my system should be able to find that out. And also important, should be scalable. So if I have really a huge amount of services, it should still work fast enough. Whatever this means, this is really use case dependent. Okay. Then why do we choose a rule-based solution here? What the factories we worked with so far have, like the only thing they have close to such a system are BPMN-based systems, but there you rather model the workflow and not describe the services. So you don't have, the system does not really understand the semantic, understand the services. It's not that adaptable, so if something unexpected happened, it can just react if I model that beforehand in my workflow descriptions. It's not that easy to add or remove new services. I can always do that, but normally if I want to use them in workflows, I don't just add a description, I add a whole workflow description, not just a service description. And yeah, it's not that flexible also. Yeah, if I have a new, what I wanted to say there, therefore I had to skip that. What I wanted to say there was, if I have a new goal to reach, I really have to describe the new workflow again. But those systems are normally, those workflows are really fixed. They scale. Yeah, okay, they don't scale while composing the services, but they scale really well by if you want to execute the services. Because then you can optimize a lot of things. So for fixed workflows, which get repeated really often, the systems they have are really good. And on the other hand, our rule-based solution can understand the services, is adaptable, is configurable and flexible. And currently it's also scalable, but I didn't dare to already put a green check mark in there because I think we still have to do more tests and have to have more implementations to be sure that it scales. So it looks good, but it's not, I can't guarantee that yet. Okay, so we chose the rule-based solution here. And now I'll explain you a little bit more about the rule-based solution. So we use RESTdesk. RESTdesk is a formalism to describe RESTful web APIs. And we do this by means of existential rules. And those existential rules are written in N3 logic. And now I will show you an example. The example will be if I have a certain part with a part ID, I want to get the production parameters for this part. So this could be material of a part or measurements of the part or things like that. So a RESTdesk description always consists of 3 parts. First of all, we have a precondition which basically says, what do I need to call the service? Here I need the part and its part ID. Then we have a request description. That is the HTTP request we actually have to perform. Here, this is a GET request to a certain URI. Note that there's a variable in there. So this question mark ID in N3, universal variables always start with question marks. So we do the GET request for this particular part ID. And then we have a post condition. The post condition always explains us what we would get by this call. So here we would get production parameters. Again, interesting here is these parameters are a blank node. So this means they are also variable, they are unknown information. And to stay complete, I just quickly show another rule because I want to use that later in the proof. Here we have another description. Here we just use the parameters we could retrieve from the other rule. We do a post request to a machine. This machine would then compose, would then produce a part. Okay, and what else do we need to actually have an example here? We need knowledge. So here I just chose a cog, and suppose that this cog has a part ID, which is 27. And then we also need a goal to reach. And what we want to do is we want to produce an instance of a cog. Okay? So we give all this information now to the reasoner. We give the knowledge we have, we give the rest descriptions, and we give the goal. And then the reasoner composes a proof. And the nice thing of this proof is we can use this proof by a generic N3 reasoner as a workflow description. So every inference which is ever done to reach the goal is also shown in the proof. And we see here we have a first step, which is lemma 3. There were more lemmas which were more like extraction of the data. So those are the two interesting lemmas. So one of them is contains the description of our step 1, which is getting the parameters for our part cog. And the other one would be the second step, send the parameters we got to the part producing machine. Interesting here is also that, I can show that here the question mark variable before is instantiated here, so we can do this call, while on this step 2 we would need here, if we would ask the query, we would need here some value to send to the machine. So it would need real production parameters which aren't there yet. So this query is this HTTP call is something we could not do yet. Okay, so in more detail what we had before, I said this one, I just copy-pasted this part from the proof. So this is the description of the call we can do. So we would here have an HTTP request description, the GET I said before. We would then send the GET request, would get some information back, like here the radius, width, and material of our cog. And then we could use this data to instantiate this post condition we had before. So now the cog has production parameters, and this SK2 is not SK2 anymore. Now we really have information and we can put it in there. And using this data, we could then start the reasoner again. And then the reasoner could provide a new proof. And the interesting part of this new proof is it is then shorter. So that one step we had before is not there anymore. And we could now really have a new step 1, a new executable step, which would be sending the parameters to the machine to produce the part. And to give you an idea, so if this wouldn't be... Hello. Okay. Okay, but yes, still the part. So if this wouldn't work, if we would get this information back, we would just not have a shorter proof. We could cope for that by not having the service in there anymore. And then if there are other services to reach our goal, we could still come up with another plan, and this is the idea of the algorithm. Okay, so this was more or less the idea behind that, and the status of our implementation is, I also put one slide to send to tell who the partners are, because that's always important for them. So we do all this work in our project Facts for Workers. The idea there is, so it's a EU project, and what we do there is we improve the working conditions for workers in factories, and all those research institutions and factories and other partners in there. So this is more or less with whom we work. And now I will present the status. So we are currently implementing that. We were already able to implement some use cases there. Results are, at least from our point of view, promising, but we did not test them in the real factory yet, and I expect some. So I'm optimistic, but I wouldn't say that it's perfect now, because we really have to test now. And also the current solutions work pretty well, and they even scale pretty well, but the services we have in there are still limited. So the number of services we combine are not that big, and also we did tests, which were good, but what I noticed is that that when you create tests, you normally don't do the corner cases. Well, people who have no idea normally write rules which can be more evil, so I expect there that something could happen. And also remember, we have existential rules there. Those can also cause problems, but the good news is we don't want to have every proof or every consequence of our data. We just want to have one plan, so we can use different reasoning strategies, which is what we are currently doing. The reasoner we use, the AI reasoner, supports different strategies, and till now it worked really well if we worked with different strategies. And this is how we hope to handle possible scalability problems. Okay, that was it. As a conclusion, I can say that what we've seen is that rule-based reasoning and proofs without any modification, that's interesting, can already help to organize work in smart factories. So we just have a special way to write the rules, but the reason is not modified by us. It's an existing reasoner, and it's already nice, or at least from my point of view, a nice plan, or a nice idea. Yeah. Okay, that was it. Questions?
How expressive is the composition language? Because you position it as a local language comparable to PML.
Yeah, I position it that way, but the difference is, if I have BPMN, I actually say how the workflow should be. While here I just say which services I have. So it's a totally different approach, and I think for both you have use cases where one is better or the other one is better. But I normally have problems if I talk about workflows, normally people expect to modify or to model the workflow, and this approach is somehow different. Okay, yeah.
Well, speaking of Doerthe, are you aware of the work on declarative process modeling, so declare and similar, where essentially you give a kind of logical representation of the business processes, and then you generate the process automatically from the declarative specification?
I know of declare. I'm not that into it yet, but I thought that you still also put more constraints on the process models themselves, or on the processes what they should have. But I'm not sure. If I'm wrong, please just tell me. Yeah.
Do you ever have workflows with repetitive operations?
Yeah, that's a good question. Actually, we have. But we can't say, of course, here that do something till a certain thing is hold or something like that. So it's never in the proof itself that it's already in there that something has to be repeated. But what we can model is we have follow-up rules which can check whether something is as expected, and then we can repeat that.
Future termination.
Is that just because your post conditions are ideological rather than numerical variables? Why can't you count?
Because we combine services and we don't describe the workflow.
No, I mean, you're specifying your services as a set of preconditions, as a post condition.
Yes.
If a service increments something, then you would think the post condition would be that the thing is incremented by 1.
Yes, but the way I put it, or we put it here, is we don't really know the result. This was why we put it in a variable. So the idea is you call the service, you get something back, and this something could be of any nature. So we can't simply say that we get a certain value back, because why would I still do the call if I have this then already in my database? But
perhaps I'm misunderstanding what those things mean. I was thinking that your pre and post conditions work like they did with a nonlinear planner, where you're chaining these things together.
yes.
Well, then tell me, how does your reason work? I suppose that's what I'm asking.
The idea of I'm reason independent actually. So the reason it just shows a proof with all those rules in it. And
I think it generates the parameters that she needs in composing, the plan, executing the instantiation of the file. It's also it's sort of deviating from the VPNN model to service oriented.
Yes, of course, but is it actually planning a sequence of services which will achieve a goal?
it is planning, but what we always have is we get a whole proof, but there's only one step we can actually execute, which is the exact next step.
Yeah.
And then we have the plan, but this is on logic level. Then there's a different component in the, let's call it the real world, where we actually do the call and get information back, and that's the moment when my information gets instantiated, and then I make a new proof.
I worked on something very similar a long time ago. Perhaps you should talk about it over a coffee.
Yeah.
So could you have different parties send requests and orchestrate, let's say, so that you could create more than one part, have a job for one part and take notes and come back to it?
Once again, because I didn't get the end. So the question was whether I could also ask for more than one pass.
Right, so you have, for example, say suppliers make requests, service requests to the factory, whereby they're supplying, different plans depending on master, say, material, so that they can create a composite part.
We have plans to do that, but currently the whole idea is that we always just have one plan and maybe some selection, but it's not. We actually also plan to do that in the future, but currently it's just one way to the goal, and we don't care how exactly we get there.